All right, so we're going to be working on sum and difference formulas. Now here's the thing. Every once in a while, you're going to get an angle that's not on the unit circle. Yes, you have to use a unit circle for this section. And so if you don't have an angle on the unit circle and you can't use a calculator because your teacher's mean and won't let you, you can use something called the sum and difference formulas. Now you should have a formula sheet, so I'm not going to write the sum and difference formulas on here. But here's the thing. See, 15 degrees, that's an angle that's not on the unit circle. But if we look at the unit circle, we have 30 degrees and we have 45 degrees. And if you notice, if I take 45 minus 30, we get 15. That's a big deal for us. See, we're going to do that all the time. We're going to take all these angles that are on the unit circle and we're going to subtract them or add them and see if we can get that angle that we're looking for. And since 15 degrees is 45 minus 30, I'm going to rewrite this cosine. I'm going to rewrite it as the cosine of 45 degrees minus 30 degrees. Okay? So now we have that formula that says the cosine of u minus v equals the cosine of u times the cosine of v plus the sine of u times the sine of v. So it's a formula that we're going to use. And you'll notice that u is going to be in the first ones. And so our u is going to be 45 degrees. And then v is in the second part. And our v is 30 degrees. And so we just use the formula. We're going to take 45 and I'm going to plug it in right there and right there, because it's the first one in this formula. And I'm going to take 30 and I'm going to plug it in right there for v, and I'm going to plug it in for v there because it's the second one in this formula. So let's see what that looks like. So we've got the cosine of u, which is 45 degrees, times the cosine of v, which is 30 degrees, and then it says plus sine of u, the first thing, 45 degrees, times sine of v, the second thing, 30 degrees. And now that I have angles that are on the unit circle, I can go ahead and just know my points on the unit circle. And cosine of 45 degrees is root 2 over 2. Same thing with the sine of 45 degrees, root 2 over 2. We have a plus there. The cosine of 30 degrees, that would be root 3 over 2. And the sine of 30 degrees is 1/2. And these things get multiplied times the ones before it. And so if I multiply, the root 2 times root 3 is root 6. And 2 times 2 is 4. Plus, the next one is root 2 times 1 is root 2. And 2 times 2 is 4. So I can write this a couple ways. Let me point out, you cannot add square roots that are different. We can multiply them. We can multiply those all we want, but we cannot add square roots that are different. So this is the square root of 6 plus the square root of 2 all over 4 is our answer. Or you could have just left it like that. Okay, so let's just keep on practicing this. So let's say sine of 15 degrees. Now I purposely kept the same angle. Remember, 15 degrees is 45 minus 30. Only now we're looking at sine. So we're going to be rewriting this as the sine of 45 degrees minus 30 degrees. So then we'll use the formula for that. And if we follow the formula, it says take the sine of u, which is our first one, 45 degrees. And then it says take it times the cosine of v, which is the second angle, 30 degrees. And it says minus the cosine of u, 45, times the sine of v, 30. Okay, now I want to point out, we don't take this minus and put it anywhere. The fact we used this minus to use the right formula. The formula had a minus in it. And then we copied on the formula exactly, and notice it had a minus right there. Okay, then we go ahead and find out sine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Minus the cosine of 45 degrees is root 2 over 2, and the sine of 30 degrees is 1/2. This will always seem familiar just because there's only so many numbers on a unit circle. So you'll have a lot of numbers repeating that you've seen before in previous problems. But here we get the root 6 over 4 minus root 2 over 4. Or you could rewrite that as root 6 minus root 2 all over 4. Notice again, we cannot add or subtract these when they are different. If they were the same, that'd be fine, but not when they're different. All right, another problem. 75 degrees. Now, I'm using numbers in the first quadrant that you can put together with the first quadrant, but you can also work outside of the first quadrant. You could go to second, third, fourth quadrant and work on that. But 75 degrees, I believe, if we look at that, is 45 plus 30. So now I'm going to rewrite this as the cosine of 45 degrees plus 30 degrees. So I'm going to use the sum formula for cosine. And so we look at that on the formula sheet, and the sum formula says take cosine of u, which is 45 degrees, times the cosine of v, which is 30 degrees. And then according to the formula, we're going to put a minus sign. And then sine of u is 45 degrees, and cosine of v is 30 degrees. Oops. I said that completely wrong and wrote it wrong, sorry. And so after it says sine of u, it says, gotta make sure I'm the right one here. This is cosine, addition, it says take it times sine of v, 30 degrees. And then I go to my unit circle, and cosine is root 2 over 2. The cosine of 30 is root 3 over 2, minus sine of 45 is root 2 over 2, and the sine of 30 is 1/2. This seems very familiar. We get root 6 over 4 minus root 2 over 4. They're not all going to be identical like this, but I just apparently am not very good at picking examples. All right, let's look at another one. Oh, this is in radians. This is where radians really are not fun to work with because we have to get pi over 12. Now, if you think about our unit circle, right, this would be pi over 6. This would be pi over 4. This would be pi over 3. Now, if I look at this, pi over 12, 3 times 4 gives me 12. So if I'm looking at common denominators, right, if I was to get a common denominator, I would multiply by 4, I'd multiply by 3, top and bottom. So now we have 4 pi over 12, and then this one is 3 pi over 12. And if I want to get pi over 12, just 1 pi over 12, I'm going to subtract these. So I can rewrite this as the sine of 4 pi over 12 minus 3 pi over 12. But you know what? 4 pi over 12, that is pi over 3, and I know that better. So I actually want to write this one as pi over 3, and I'll erase this one too. Oh, I can't erase it. Oh, no. Let's rewrite it then. Sine of, instead of 4 pi over 12, I'm going to write pi over 3 minus, and then pi over 4. And I use a sum formula, or sorry, the difference formula for sine, which is sine of u, and u is going to be our first one, v is our second one, so sine of pi over 3, and then cosine of pi over 4, and then it has a minus, and it says cosine of the first one times the sine of the second one. And sine of pi over 3 is, what is that, root 3 over 2? Cosine of pi over 4 is root 2 over 2, minus the cosine of pi over 3 is 1/2. The sine of pi over 4 is root 2 over 2. So now we have the square root of 6 over 4 minus the square root of 2 over 4. And you'll notice that this is actually very much similar to one we've already done, but that's because we have the same angle. This is really 15 degrees. All right, let's do something different. So this is a little bit more in general. It doesn't tell us what angles we're working with. It just gives us some information. So you'll see that they want us to find the sine of u plus v. And then they don't tell us what u and v are. Instead, they tell us that u is between 0 and pi over 2. So let's get an xy axis on here. It's between 0, which is right here, and pi over 2. So it's somewhere in the first quadrant. So I'm just going to draw a triangle in the first quadrant. Let me color code here. So we'll make u blue, okay? And then if I go and look at the information they gave me, sine of u is 4/5. Sine is the opposite over the hypotenuse. And so then if we do the Pythagorean theorem, we find 3 for this side. Then we have the other information. They told us v, and if you notice it says v is between pi over 2 and pi. Well, pi over 2 is here and pi is here. So they're telling us v is in the second quadrant. And then what else they tell us? Cosine is negative 12 over 13. So we go negative 12, and then we go 13. And if we do the Pythagorean theorem, we get a 5 here. Okay? So, of course, you'll probably end up doing the Pythagorean theorem more than me. I've just become very, very familiar with these two triangles. So now let's go back to what they wanted us to find up here. They want us to find sine of u plus v. So we've got sine of, and then we had u is blue, plus, and v is green. All right, so let's go ahead and write out our formula. The formula says the sine of u times the cosine of v plus the cosine of u times the sine of v. All right, let's look at the sine of u. The sine of u, if we look at it, is opposite over hypotenuse, so I can do that. Opposite over hypotenuse. The cosine of v, let's see, here it is. Cosine of v is adjacent over hypotenuse. So we've got times negative 12 over 13. And then we have the cosine of u. So I'm back at u. Cosine is adjacent over hypotenuse. That would be 3 over 5. And then the sine of v, here's v. Sine is opposite over hypotenuse. Sine is 5 over 13. And we'll multiply those. And then as I do that math, let's see, we've got nothing that cancels here, so we just multiply negative 48 over 65 plus, and then 3 times 5 is 15 over 65, and then we can go ahead, add those together, and we get negative 33 over 65. All right, so that's how we would find that. It's a little bit more in depth, but you can rewatch it if you do. And then we have one more type of problem that we're going to look at in this video, and that is if we're going to write this as an algebraic expression. Algebraic means no more cosine, no more sine. We just have x's. It's going to look a little bit silly. There's going to be a lot of square rooting going on. All right, so let's just start with we'll start with arctan of 1. So basically, if we look at the big picture of this, I'm trying to find the cosine of these two things being added together, but this is too much. I need to simplify it a little bit. I want this, I'm going to call it u because that's usually what we call it, okay? So if I work that out, I've got arctan of 1 equals u. Well, let's rewrite that. So tangent of u equals 1. And then I'm going to go to the other one. I'm going to call this v. So that means the arc cosine of x equals v, and then I'm going to rewrite it as the cosine of v equals x. All right, so here's what we're going to do with that. Now what I've done is I've simplified it down, so now I have the cosine of u plus v. Or if I color code it, I suppose, u plus v. Okay, and so then I have the cosine of u times the, what is the sum formula? Cosine of v minus the sine of u times the sine of v. Okay, but in order to do this, I need to actually know what the cosine of u is. And the only thing I know about the cos of u is the tangent of u equals 1. So what I can do is I can set up a triangle. I'll just do it over here on the side. Set up a triangle, and let's call this one u. And tangent is 1, and I need that to be a fraction, so I have opposite over adjacent. So 1 over 1, use the Pythagorean Theorem, we get the square root of 2. So now I can actually figure out the cosine of u is 1 over root 2. And then if I go on the other side, sine of u is 1 over root 2. And we'll just not worry. Let's not worry about the square root on the bottom right now. That's just kind of silly to worry about that. Okay, and then the other one, we have v. The only thing I know about v is that cosine of v is x over 1, so that's adjacent over the hypotenuse. And then you have to do the Pythagorean Theorem to help that one out. Let me just do it over here. So x squared plus b squared equals 1 squared. So x squared plus b squared equals 1. I have to subtract x squared. So now I have b squared equals 1 minus x squared. And then I have to solve for b, so I square root. So b equals the square root of 1 minus x squared. So when I find the cosine of v, well, that's just x over 1, right? And then the sine of v is opposite square root of 1 minus x squared over 1. Now, I bet you right now are looking at this going, holy crap, she's going to make us simplify this. And I'm not. I'm going to be kind of nice on this. So all you have to do is put things together. So in the first fraction, we have 1 times x, and the square root of 2 times 1 is the square root of 2. Minus, and the next one, 1 times the square root of 1 minus x squared over the square root of 2. Okay, and then because they already have a common denominator, I can put the tops together. I can't actually subtract them. I can just write them down as one thing, the square root of 2. And I'm done. I'm not going to even make you rationalize it. I'm not going to make you simplify anymore. This is all I really want from you, is to be able to get to this point. All right, good luck.